All right, welcome to Physics Video 4.5. This is basically an extension of what we've been doing. There's really only one new thing here, which is what we're going to be doing is solving problems, projectiles problems, where you've got an initial vertical velocity. So up until now, we've done a ton of problems where you've got whatever, a car driving off of a cliff or somebody throws a ball horizontally. But all of our problems have started out moving horizontally, which has meant that our VIY would be 0. So, and it lands like that, right? So what we're going to be doing different now is we're going to be doing stuff like this, where maybe you've got a football that is being kicked. So here's our football, and it's going to go like that, right? So the idea, though, is that because when you first kick it, it's already moving up at some velocity, there's going to be some horizontal motion and some vertical motion when you first kick it, okay? So, in the past, our VIY has always been 0. In these problems, we're going to have to find our VIY, I guess I should say. And so that's the one extra step, okay? Other than that, pretty much everything is the same, all right? So, I think before I get to the problem, let me show you this. So suppose we've got a problem. Suppose in that last problem we had kicked our football at, I don't know, a velocity of whatever. Let's just make up a number, maybe about 18 meters a second. All right? So, but when you kick it, it's going to be moving at some angle. So in this class, we're always going to measure the angle that the object is moving at above the horizontal. All right? So maybe this angle here is, I don't know, how about 22 degrees, whatever, just some number. All right, so the way the problem will be worded is it'll say a football is kicked at a velocity of 18 meters a second at an angle of 22 degrees, blah, 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 blah. All right, and so the first thing that you'll have to do is you'll have to figure out how fast the football is moving horizontally and how fast the football is moving vertically. All right, since this is initially, we can put initial over here. All right, notice we don't need to put VIX here because remember your VX is constant, so saying initial is a little bit redundant. Okay. So you actually need to use a little bit of trig. I'm not going to go through sort of the derivation of these equations, but it's just SOHCAHTOA, like you would have learned in your math class. So here's the equations we used. To find the VY, you just take whatever V is and you multiply it by the sine of this angle. All right. So this little funny symbol here that I used is the Greek letter theta. And in math and science, usually we use the Greek letter theta to represent an angle. Okay? Cool. And then if you want to find Vx, it's the same thing, except use cosine. Okay? And remember, theta means your angle. All right? So for us, what we're going to do is, to find our Vy, we're going to take 18 meters a second and multiply it by the sine of 22 degrees. So grab your calculator, type it in, and see what you get. And so that gives you 6.7 meters per second. All right, and then similarly, we can find our Vy, or I'm sorry, our Vx, but you're going to do 18 meters a second times the cosine of 22 degrees. So type that into your calculator, and you get 16.7 meters a second. All right, so put those in your drawing. Our Vx is the 16.7 meters a second. The Vy is the 6.7 meters a second. All right, so the idea is, what this has told us is that at the instant that our football is kicked, it's moving at 18 meters a second. And at that instant, it's moving upward at 6.7 meters a second, and it's moving horizontally at 16.7 meters a second. If you're not sure if you did it right, you can always check it by doing the Pythagorean theorem, right? So you're going to do 6.7 squared plus 16.7 squared, and then square root your answer, and it should give you pretty close to 18 meters a second. Now, it won't be exact because of rounding, but it should be pretty close. All right. Now, type these things into your calculator and make sure you get the same answers I got. If you didn't, here are some common issues. First of all, make sure your calculator is in degrees, not in radians. In your math class, you probably use radians. But in science, we use degrees. And then the other issue that I see people make sometimes is that they they put the angle and the velocity in the wrong spot. So make sure you find out what the sine of 22 is, and then multiply that by 18. On most graphing calculators, you can just type it exactly like that. But if you've got an older calculator or you're using your phone, boo, then you got to type it in differently. If you're struggling, then just remind me and we'll talk about it in class. All right, so that's the deal there. So let's do a problem. So here it says, suppose Roy rides his rad BMX bike off a ramp, which is inclined at 27 degrees at 88 meters a second. Then it says, how long will he be in the air, blah, 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 blah. So here we go. The first thing you want to do is make a drawing of the starting conditions. So the idea is when we first go off of the ramp, we're moving at a ridiculous 88 meters a second at an angle of 27 degrees. So we're going to need to find out our horizontal velocity and our vertical velocity. So pause the video and find those two things and make sure you get the right answers, okay? So hopefully you've paused the video, and at this point you've found your Vy by doing this. You should have taken 88 meters a second and multiplied it by the sine of 27 degrees. And if you do that, you get pretty close to 40 meters a second. Pretty close to 40 meters a second. And then similarly, if you find your Vx, do V times the cosine of your angle. So it's 88 meters a second times the cosine of 27 degrees. Then that gives you 78.4 meters a second. All right, so put those in your drawings over here. 78.4 meters a second and 40 meters a second. All right, so I'm going to solve this twice. I'm going to solve it once using a chart, and then I'm going to solve it after that using equations. Okay, so here we go. So first solution is to make a chart. So time, I don't know how much time I'm going to need yet, so I'm just going to go up to 4, and if we need more seconds, then we will. All right, let's put in two columns, Vx, Vy. I guess we're going to go past that. V, we'll do triangle X. Triangle Y I probably won't fill in here unless we need to. So remember, we just figured out our Vx. It was 78.4 meters a second. So that's going to go in my chart here, 78.4 meters a second. And remember, the first rule of projectiles tells us our horizontal velocity is constant. So these are all going to be 78.4. Oops. All right, our vertical velocity starts at 40 meters a second. Now remember, big rule number 2 tells us that every second the vertical velocity decreases by 10, right? So usually we start at 0 and then subtract 10. Now, because we've got vertical velocity, we're going to start at 40 and subtract 10. So right now it's moving up at 40 meters a second, moving up at 30 meters a second, moving up at 20 meters a second. Notice it's slowing down how quickly it's going up until it stops going up. This point right here is huge. That's where you're at the top of the path. All right, so we need to keep going then. If it took 4 seconds to go up, it's going to take 4 more to come down. So we're going to have, now it's coming down at 10, now it's coming down at 20, 30, and 40 meters a second. Now it's back to where it started. All right, to fill in the B column, you're going to just do the same thing that we've been doing. You're just going to fill in the Pythagorean theorem. All right, so I'm not going to write that out. You guys all know how to do that. I will, however, write in the results that you get. All right, so if you do the Pythagorean theorem, these are the results you get. Notice 2 of these shouldn't be a big surprise. We knew that, right? That's how fast the motorcycle or the bike was going when it went off of the ramp. And when it gets to the top of the path, all of the motion is horizontal. So notice, at the top of the path, my velocity is 78.4 because that's what my horizontal velocity was. There's no vertical motion, so all the motion is horizontal. All right, then to get this, this, and this, I just used the Pythagorean theorem. So really, I only had to do that 3 times. And then to fill in the rest of the chart, they just repeat, because now it's coming back down again. So you just get these. All right, so there's your V's. To find your delta x, it's just Vx times t. So take whatever your Vx is and multiply it by your time. So in 0 seconds, you're not going to go horizontally at all. After 1 second, you'll have gone 78.4 meters. After 2 seconds, you'll have gone 156.8. After 3 seconds, you'll have gone 235.2, etc. So those are the results that you get. All right? And then your vertical displacement, you got to use this equation. So remember, your AY is always going to be -10 meters a second squared. Your VIY for this problem is always going to be 40, because that's what our VY started at. And then your time is whatever you got. So here's the answers you get. You get those guys. All right. So I probably wouldn't have you fill out one of these for a test because that would take a long time, right? Okay, so there's the deal. So to do it with your equations, what you're going to do is you're going to start with your drawing. You're going to go, okay, well, I know that my starting velocity is 88 meters a second. I know this angle is 27 degrees. You're going to find your Vx by using V times the cosine of your angle, and that gives you the 78.4 meters a second we had before. You're going to find your Vy by doing V times the sine of the angle. That gives us 40 meters a second. Then you're going to draw it and write down what you know. So at this point, here's what I know. I know that my velocity is 88. I know that my Vx is 78.4. I know that my Vy is 40. Over here, I know my velocity is going to be 88 meters a second again. My Vx is still 78.4 meters a second, but now my Vy is negative because it's coming down, right? All right, a lot of people want to make this guy over here, this negative, and you don't really. I know you're thinking because it comes down, but because we're talking about two-dimensional motion here, just using a negative isn't enough information. So technically, we'd have to give an angle, and you'd say, well, the velocity is 88 meters a second at 27 degrees below the horizontal. All right, finally, we know that up here at the top, I know the Vx is still 78.4 meters a second. I know my Vy is 0 because it stopped moving, and so my overall velocity is 78.4 meters a second. All right, what I don't know is the time to get to any of those points. All right, so the questions ask, what do the questions ask? I don't remember. How long will it be in the air? So, for question A, we're looking for the amount of time it takes to get from here to here. So, we're going to use that guy. So our VFY at the end of our time is -40. Our VIY at the start of the time is +40. And then our AY is -10. So divide it all out and you get 8 seconds. Write it on your drawing. The time to get here is 8 seconds. And then automatically I know that the time to get to the top is going to be half of that, 4 seconds. Cool? Question B, how far away will it land? Well, I'm looking for my horizontal displacement, right? So it's just Vx times t. So my horizontal velocity was 78.4 meters a second. I want to know how far away it's going to land. So I'm looking for this displacement, right? From here to here. And in my last drawing, we discovered that it took 8 seconds to get there. So that's the time you want to use. So multiply that out. Whatever it gives you is your answer. That turns out to be times 8 gives you 627.2 meters. All right. I didn't ask you this question. I wish I had. Let's figure out how high does it go at the top. So now I'm looking for from here to here my change in y, right? So here's what I know. I know that my VIY is 40 meters a second. I know when I get to the top, my VFY is 0. I know the time to get there is 4 seconds from my last drawing. I know my acceleration is -10 meters a second squared. And I'm trying to find my displacement. Vertical. So plug in your numbers. Acceleration is -10. Time is 4 seconds. Don't use the 8 seconds. We're trying to find how high it is at the top. And it gets to the top after 4 seconds, not 8. Our VIY was 40, and our time is 4 seconds. So multiply that out, add it all up, and you get 80 meters. Cool. All right, and then finally, to find the velocity after 4.5 seconds, or 5.5 seconds. Question C. Time is 5.5 seconds. We're trying to find the velocity. So the idea is time is 4 seconds, time is 8 seconds. So over here is going to be 5.5 seconds, and I want to find that velocity. So to find that velocity, I need to know how fast it's moving horizontally, and I need to know how fast it's moving vertically. So it's a two-step process. First of all, I know my Vx is 78.4 meters a second because it's constant, but I got to find my Vy, and this is the step people always forget. So Vfy equals Viy plus Ay times t. So my Viy was 40, my acceleration is negative 10, the time is 5.5 seconds. Multiply that out and you get negative 15 meters a second. And now we can find our velocity. So to find the velocity, remember it's Vx squared plus Vy squared, and take the square root, right? So 78.4 squared plus negative 15 squared, square rootified, and you get an answer of 79.8 meters a second. All right, thank you so much. I don't know why I'm saying thank you. We'll talk more about this in class.